week, tomorrow, which is Wednesday, homework 17 is due. And then on Thursday, we have a skills check. And that skills check is over 9.4, which is pages 1 through 4 in your notes. And then on Friday, homework 18 is due. So I pushed everything back because I know yesterday was senior skip day and I just, Now also, I did teach a lesson yesterday. It was 15 minutes in total. So if you watch it at 2.0 speed, you can be finished in 7 minutes. We did page 5. Okay, so make sure it's your responsibility to make sure you watch that video and take notes for that. Any questions about this week? So all of the due dates are on the board. We'll be finished with this unit Tuesday and you take a test next Friday. Okay, so let's look at that gold sheet that I gave you, which is the bell work. Now, in your notes, if you go to page 2, at the top of page 2, in your notes, there are some formulas that you need to have memorized. Now, this right here, if you want to write on there, this is 9.4 material. So this bell work is 9.4 material. This is the kinds of questions that will be on your skills check. So if somebody, look at the top of page 2 to get your formulas. All right, so the formula is for magnitude. The formula for magnitude is the square root of, and then that would be delta x squared plus delta y squared. That's how you find the magnitude. The formula for direction, which we just usually just call that theta, is the inverse tangent of delta y over delta x. So again, those are formulas. They won't be on the test. They won't be on the skill checks. You need to memorize those formulas. So let's go ahead and find delta x. Delta x equals x2 minus x1. So I'm going to label this. This is my x1, y1. This one is my x2, y2. So in order to find the change in x, I'm going to subtract these two numbers. So that would be 2 minus negative 2. So what do you think you get when you take 2 minus negative 2? Anybody know that without a calculator? You get 4 because it changes to addition. Good. Now we're going to find our delta y. For delta y, we're going to take y2 minus y1. y2 minus y1 would be 8 minus 1. I'm sorry, 8 minus 7, which is 1. So if you were to write your vector in component form, your vector would be written like this. That's my vector. All right, so I want you to use those two to find the magnitude. So for magnitude, we're going to take the square root, and that would be 4 squared plus 1 squared. See what you get. For your direction, it would be the inverse tangent of y over x, which would be 1 over 4. And everything is to the thousands place. So x is cosine and y is sine. All right, so I did not convert that to a decimal for the first one. And I would not mark it wrong if you kept it as the square root of 17. So that would be right, or you could type it in your calculator. And then for the inverse tangent, what did you all get for that? Oops. 14.056. 036. All right, who agrees with that? And that's it. Now keep in mind though that this is in Q1 because that is where we have a positive X and a positive Y, which means that this answer has to be between 0 and 90 degrees. And in this example, we actually got that, so we don't need to add 180 or 360. All right, now go to the top of page 3. This is another set of formulas you need to know. This is the symbol for magnitude. So if you look at the top of page 3, you should have the formulas for delta X and delta Y. I believe this was on the video. Well, no, was it? I can't remember, y'all. My brain, I don't know. All right, so delta X is going to be 9 cosine 35. Delta Y is 9 sine 35. Go ahead and type that in your calculator. And we're going to write that in a vector bracket. Okay, so 9 cosine 35 is 7.372. And then 9 sine 35 is 5.162. That is your component form. That's how you find it if you're given magnitude and direction. So you need to have those formulas memorized. Any questions? All right, so we're only going to do page 6 in our notes. So let's go ahead and go to page 6. First formula on page 6 is work. I need to double check, but I'm pretty sure this is something you need to memorize also. I'll double check that as we get closer to the test. Well, I guess I need to look now because the test is next week. But the formula for work, I'm just going to write what this means, is you're going to take the force, which is also, you can also think about that as the speed. And then you're going to take that times the distance. And then you're going to take that times the cosine of theta. All right, so let's go ahead and read number 1. Number 1 says a boy pulls his brother in a cart with a force of 22. So that's important. If the rope pulling the cart forms a 38-degree angle, so we got our angle, with the ground, determine the amount of work done for him to pull the cart 25 meters. So we got our distance. So we got the 3 numbers we need. So work is going to be force times distance times the cosine of 38. Go ahead and type that in your calculator. All right, I got 433.406. Anybody else get that? All right, go ahead and do number 2 by yourself.
What do you label work as?
Okay, the unit of measure, you would multiply your unit for force and distance. So you could say this is newtons meters. Or you can also say for that one, that's joules. That would be your unit. All right, go ahead and do question 2 all by yourself. We got find the work done by a force of 3 pounds acting in the direction of 60 degrees to the horizontal moving 9 feet. So some calculators may write it as a fraction, or you can write that as a decimal. And the unit of measure would be force units times the distance unit. So for that one, you could say it's pounds times feet. So pounds feet times feet. Okay, any questions? All right, now we're going to get to the nitty gritty. Numbers 3 and 4. All right. So number 3, we have an airplane that has a horizontal component of 300 and 500. So I'm going to stop right there. So they gave me the component, so I don't need to find it. They told me the horizontal is 300. The vertical is 500. So I'm going to write that down. So my plane is 300, 500. Okay. Resulting in the magnitude of 583. And that's not important because we just really need, we don't need that. Okay. If wind is blowing 40 miles per hour. So now I'm introducing another vector, which is wind. So it told me that the wind is blowing 40 miles per hour from the east. So it didn't tell me the horizontal and vertical component for the wind, so we have to find that. So in order to find, I'm going to write it over here, for the wind, remember, delta x, if we look back at the top of page 3, that's going to be your speed or your magnitude. Your speed is the same as magnitude. So that would be 40 cosine angle and 40 sine angle. But here's the thing that might be a little confusing. What direction is the wind blowing? Who says east? Who says west? So the key word is that it says it's blowing from the west. If I'm coming from the west, it says it's blowing from the east. So it says from the east. So that means it's going west. So what you need to know also, I don't know if you all would connect this, but if I ask you what is the measurement of this angle over here, I don't know if you would remember that that's 180, where east is 0. So you may want to write in your notes that if you're blowing to the west, then theta is going to be 180. But if you're blowing towards the east, theta will be 0. And that's all you're going to use for theta, for the wind. So I need to figure that out. So I don't know that. So we have to find that first before we can write that in vector form. So I have delta x That's going to be 40 cosine 180. And then my delta y for the wind is 40 sine 180. So let's go ahead and figure out what you get for your wind. We need the horizontal and vertical component for the wind. All right, so you should get negative 40, 0. Who had that for the wind? All right, so it's asking us for the result. So the result is going to be what we get when we take the force of the plane and add it to the wind. So we need to figure out what the plane plus the wind vector would be. So we do that by adding our x's. So when I add those together, I get that the plane and the wind combined would be 260. That would be my horizontal component. And when you add 500 plus 0, you get 500. So I want you to use these two numbers. This is the numbers I'm going to use to find my magnitude. So it's asking for speed. Speed, to find speed, we use our magnitude formula. So I'm going to take the square root of 260 squared plus 500 squared. Go ahead and see what you get. Type that in your calculator.
Wait, why did you do that?
So that's the formula for magnitude. So it asks you at the end, what is the plane speed? So if you're trying to find speed, we use our magnitude formula, using the horizontal and vertical component of the plane plus the wind, though. So type that in your calculator to get your speed to the thousands place. And I don't know, I think the next number must be a 0, but you know, speed is measured in miles per hour. Then I want you to find the direction. So let's find the direction, and then we'll talk about heading in a second. The direction is going to be inverse tangent of y over x. Go ahead, type that in. All right, so when I type that in, I need to redo that because I didn't round my answer. So let me do that. Inverse tangent of 500 over 260. I got 62.526 degrees. Anybody else get that? All right, so let's talk about that. 62.526. Okay. Whenever you're asked to find the direction, your direction is this angle here. That angle, this is direction. But they want the heading, which would be this one. So if I know this, I figured out that this angle here is about 62.5. And we know this is a 90-degree angle. How would I find the heading if I know the direction? Subtract it from what? 90. So I'm going to go ahead and write that formula just in case, because I know half of y'all daydreaming, and that's okay because we all tired. Last day of school is 1 month from today. So your heading is 90 minus theta, which would be 90 minus 62.526. So go ahead and type that in your calculator. and I get 27.474 degrees. Is that what you all got? So this is my final answer. I'm gonna put it in gray. So this is my first answer. That's my speed. And this is my heading. So the main thing is we have to figure out what my two forces are that are acting against or acting together or acting against each other. Figure out your vector and then use that to find the magnitude and the direction. All right, last one for today, and then I'm gonna show you your tests. They've all been graded. So we got a soccer player running forward at 7 meters per second. So the soccer player, this 7 meters per second, that is his magnitude. And then he kicks a ball. The ball has a velocity of 30 meters per second. So that's the magnitude of the ball. And that ball is going at an angle of 10 degrees. So we have two things working together. I have my soccer player, which is going this way. And then he kicks a ball and the ball goes like that. That's the second vector. So we got to figure out, if we were to combine that, what I'm really trying to figure out is what would this vector be? That's what if I put those together, where would I be? All right, so let's talk about the soccer player. So soccer player, they did not tell us his horizontal or vertical component. So I know I have 7 cosine. What do you think the angle is I'm going to use for the soccer player? If he's going forward, do you think I'm going to use 0 degrees? Because it doesn't say, like, we're going to assume he's running on a flat field. Like, I don't think a soccer field is hilly. I don't really watch soccer. I'm pretty sure it's just a flat field. So if he's running on a flat field and he's going forward, am I going to use 0 degrees or 180 degrees? Who says 0? Who says 180? It'll be 0. So again, if you do that, never eat soggy waffles. Oh yeah, I see why my pen isn't working. It's because this is not working that well. I gotta replace that pen. Okay, so we got that, and then we have 7 sine 0. It's not working. I feel like fighting with this no more. So we got 7 sine 0. So use your calculator to figure out the soccer player's horizontal and vertical component. So the soccer players, go ahead and find the soccer players. So 7 cosine 0 and 7 sine 0 will give you 7 0. Now we got to add to that the kick. So his kick, they told us the angle and the magnitude. So we're going to take 30 cosine 10 and 30 sine 10. Go ahead and see what you get. To the thousandths place. You can check my numbers because, again, I did this last year, so it doesn't mean it's right. So to find my result, I'm going to add these together. So I want you to add your x's together, and then I want you to add your y's together. So my result vector, Soccer player plus kick. Soccer plus kick is going to equal. So 29.544 plus 7 gives you 36.544. And then 0 plus 5.209 is that. So I want you to use that vector to find the speed. So using this vector, let's find the speed. Remember, speed is the same formula as magnitude. So his speed is going to be the square root of 36.544 squared plus 5.209 squared. See what you get for his speed, or the speed of the kick. It's not the player speed, it's the speed of the kick. So the ball and the force he applied to the ball. So go ahead and type that in to get the speed of the kick. Okay, that's what I got. So this is not in miles per hour. This is in meters per second. That's the speed. So that's your first answer. And then notice it's asking you for the direction. So we don't need to subtract anything. We just need to find our direction. So theta is going to be the inverse tangent of your vertical component over your horizontal component. Go ahead, type that in. Anytime you're looking for an angle, we have to use inverse. Inverse inside. Angles and inverse. So make sure you hit the green key first, then hit tangent. And I got an angle of 8.112 degrees. Did anyone else get that answer? And that's your two answers. So in my opinion, pages 6 and 7, that's where it's going to get a little icy for the test next week, because, you know, that's word problems. And then at the very end of the packet, when we get to chapter 10, those are going to be a little icy also. 11 through page 14, I think. So that is my opinion.